Hello everyone, welcome to the stream. Today is the fourth class of our machine learning series. I hope my voice is audible. Can I get a confirmation in the chat box if my voice is audible? Thank you all for joining. Okay, in the meanwhile, let me just give a quick introduction on what's happening right now. Some of you might be joining this for the very first time. So, we are doing machine learning live classes, right? This is the fourth class of our machine learning series. So far we have already done three classes, so almost 6 hours of free contents are already provided, right? In case you have not watched any of our videos so far, please attend the class, today's class, and after today's class you can go and watch out the previous 6 hours of videos. Okay, so far we have covered almost many topics, like basics of machine learning, types of machine learning, classification algorithms with a simple practical case study. We have also covered regression algorithms, simple linear regression and multiple linear regression, right? Today we shall be jumping into the practicals of regression. So we have a case study, we will be taking that and we will be using that for our exercise. Going forward, we will be doing clustering, and I think that should be the end of this class. So we are aiming to finish the practicals of regression. Yeah, I forgot one thing. We have to also cover polynomial regression. So I'll cover polynomial first, and then we'll go for the practicals, and then we'll jump into clustering. So quick recap on yesterday's class. um, so we started with regression yesterday. I think we started with support vector machines. Anyways, about regression, just a quick recap. So we took an example of house price prediction, area and price, where if you want to predict the price is going to be the y variable and area is going to be the x variable, right? And we did all these things. We plotted the data points into the graph, and then our main goal is to identify the best fit line, and then from the best fit line we were able to get the best fit line. And once you get the best fit line, then you can do the predictions, right? So let's say you have some data points like this, like this, like this, like this. Let's say this is your best fit line. Now if your question is 700 area of square feet, what will be the price? So you have to take that value in your x-axis and try to plot whatever the corresponding y value will be. That's our final prediction, right? That is what we studied yesterday. In real time scenarios, price actually is not only dependent on area but also dependent on multiple other factors, right? So that makes a problem from a simple linear regression problem to a multiple linear regression problem. So your problem equation changes from y is equals to mx plus c to y is equals to m1x1 plus m2x2 plus m3x3 and so on. That is what we studied yesterday. Now, we will be talking about the last algorithm, polynomial regression. The reason why I want to focus less on regression is there are multiple reasons. Let me first teach you what polynomial regression is. Let us go through some of the practical codes, and then I will tell you why I usually deprioritize regression. Um, I usually not only in this YouTube live class, even in my real time live classes when I used to teach, anywhere I teach machine learning, I usually teach regression for a shorter period of time. Instead, I focus more on time series analysis and forecasting, because in industries we usually don't have a lot of regression problem use cases. Most of the use cases are time series problems. And when the problem statement changes from regression to time series, the statistical knowledge, everything changes. The algorithms, the way you solve a problem, everything changes. Okay. So, Dipinder, today's topic is continuation of regression. So yesterday I covered simple linear regression and multiple linear regression. Now we are going to cover polynomial regression, and then we will jump into our practicals, and then we will go for clustering. In clustering, we will be covering k-means and hierarchical clustering both, and then again we will go for a case study. Okay. Any questions that you have, you are posting it on live chat. If the question is not relevant to what I am teaching, I will answer that in the break. Okay, clear? Narotham has a question. Good evening, everybody. Narotham has a good question. Is the Y interpretation, is the Y interception C? Y interception C is common in MLR. What do you mean Y interception C? You mean is the constant value? Oh, you're talking about the slope and the intercept, right? Is the intercept common? That's your question. So so going back to simple linear regression. So here, if your data points are like this and this becomes your line, right? It is y is equals to mx plus c, right? In this case, what is c? C is simply this part, right? And m is this part, delta y divided by delta x. If you move to a three-dimensional use case, you have three features. Not necessarily the c value will be same, right? So your line could be here, it could be here, it could be here, anywhere. So intercept will change. And again, from 3D to n dimensional, if you go ahead, again intercept values will change because you are adding new features, right? Based on new features, your intercept values will change. Okay. Coming back to polynomial regression. So what is polynomial regression? First of all, try to understand this thing. Let's say I have some data points. Here you can easily draw a straight line, right? Fine. Straight line equation is y is equals to mx plus c, which if you want to generalize it, this becomes y is equals to, let's say, beta 1 x plus beta 0. See, sometimes I write beta, sometimes I write w, doesn't matter, right? These are all constant values, as simple as that. This is variable, this will vary, right? But this is a constant number, right? It is your slope and this is your intercept. So whether I use beta, I use w, I use something else, don't get confused. Okay. This is a generalized formula, right? If you move from 2D to 3D, what will be the formula? Y is equals to beta 1 x1 plus beta 2 x2 plus beta 0. Similarly, if you go to n dimensional, your formula becomes y is equals to beta 1 x1 plus beta 2 x2 plus dot 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 beta n xn plus beta 0, right? Can I write it like this? Y is equals to beta 0 plus summation of n is equals to, sorry, I is equals to 1 to n beta I x I. So we can write it like this. This is nothing but the formula of your MLR, right? Multiple linear regression problem. Fine. This is understood. What if your data is something like this? Let's say your data is something like this. Okay. Again, I'm taking two dimensions, right? 2D data, x and y. Now, in this case, if you want to draw a line, there will be certain data points which are very far away from the original line, right? So, whatever line you draw this, you draw this, you draw this. Your distances of certain data points will be very far away from these lines. So, in this case, it's always better to use a different function. So, in this case, we use a polynomial function. Okay. So, what is polynomial function? In simple terms, in polynomial function, there is a concept called as degree. Okay. Let's say I'm considering my degree as 2. What is degree? I will explain. Let's say my assumption is degree is 2. So mathematically, what does that mean? And as I am taking an example of 1x and 1y, I will take the same thing. So I have area as my x and price as my y. So you can consider this as a simple polynomial regression model. Same like simple polynomial regression, if you move to n dimensional space, like multiple linear regression, you will also have a multiple polynomial regression model. Concept is same. Okay. Now let's say given a particular area, let's say the price is 50. Degree 2, what does this mean? This means your x is nothing but having three parameters or three things. This is called as your degree. Degree 2 means you will have three things: x to the power of 0, x to the power of 1, x to the power of 2. If your degree is 4, this becomes x to the power of 3 and x to the power of 4. Okay. Now what do you mean by x to the power of 0, x to the power of 1? X to the power of 0 here is 500 to the power of 0, which is 1. This is 500 to the power of 1, this is 500 to the power of 2. So eventually it's nothing but 1 comma 500 comma 2500 25 0000. Okay. Similarly, if your degree changes from 2 to 3 or 3 to 4, there will be additional parameters here. Now why am I talking about this thing? Because this thing is being included in this equation. Okay. And this data goes into the training part. Okay. So what will be the equation of this? I cannot call this as a best fit line. In polynomial regression, we call it as a best fit curve. We cannot call it as a line, right? In linear regression, we call it as a line. Best fit curve. What is the formula here? The formula is y is equals to beta 0. Okay, I'm just rewriting the simple linear regression equation. Okay, so simple linear regression is y is equals to beta 0 plus beta 1x. In polynomial regression, I will write it down as simple polynomial regression. The equation will be y is equals to beta 0 considering degree 2. Okay, considering a degree 2, beta 0 plus beta 1x plus beta 2 x to the power of 2. Now this is nothing but your x to the power of 0. This is your x to the power of 1. This is your x to the power of 2 component. These are the three components. Okay. Got it? If you have a degree equals to 3, what will be the simple polynomial regression equation? It will be beta 0 plus beta 1x plus beta 2x to the power of 2 plus beta 3x to the power of 3. Now moving from a two-dimensional space to three-dimensional space. Okay, considering let's say the data points are something like this, and in the three-dimensional space you are drawing a curve. In this case, again considering degree as 2, multiple polynomial regression, what will be the formula? Y is going to be beta 0 plus beta 1. Let me rewrite, beta is not visible properly. Beta 1x plus beta 2, sorry, I will write it down as x1. There will also be, let's say I will write it down as beta 1 1, beta 1 2. So you can have beta 2 1 x2 plus beta 2 2 x2 to the power of 2. Now some of you might be thinking, what is degree? How do we get to know the optimum degree, right? If you go to the sklearn library, sklearn polynomial features, In the code, you will see there is a parameter called as degree. So, in short, what is degree? In short, degree is nothing but a hyperparameter. And in order to get the best degree, you need to do hyperparameter optimization. Basically, meaning that you have to run polynomial regression multiple times with different degrees to come up with the best optimum model. Okay, that's all about polynomial regression. When it comes to practical codes, it's going to be very, very simple. Just implementing polynomial features is very simple. Only the understanding the mathematical part is difficult. Other than that, coding part is not that rocket science. Nowadays, with the help of ChatGPT, you can easily write down codes, right? In our days, we were struggling. We were using Stack Overflow, we were debugging, so it was a nightmare. I will be very honest with you, like 8 to 9 years back when I started, the community was not strong. So a lot of things we had to, it was a very difficult scenario for us, at least. Writing codes was difficult, and then debugging codes, finding the right documentation, finding the right code, it was very, very difficult. Nowadays, you simply take a piece of code and ask ChatGPT, "Oh, this is my code. I have some error like this." ChatGPT will potentially fix your problem. Anyways, coming back to the case study. For this case study, for regression case study, I'm going to use this data set. Just let me show you this data set. So this is the data set that I have. Again, this is a dummy data set. Now, how many features do we have and how many? So can you tell me, looking at this data, how many x variables do we have and how many y, and what is your y variable? Just write down in the chat box. These are my x variables and this is my y variable. So here basically I'll tell you the problem statement. The problem statement is, given different conditions, we need to predict the profit. So we need to predict profit. So what is my y variable here? Y is profit, right? Simple. So this is my the y is my profit is my y, right? And in x variable there are four: R&D spend, administration, marketing spend, and state, right? Now, can I directly pass this column to the model? I have not taught this one in machine learning, but if you have gone through my EDA videos, I have already explained this part. So there is a concept called as feature encoding, right? So anybody remembers what is feature encoding? I have not taught in machine learning, but feature encoding I have taught in exploration of data, EDA video. If you go to my EDA video, just go to yeah, just go to YouTube, search EDA Satyajit. You will be, this is a 6 hours video. You will just go to this video, somewhere in the video description. You will see a chapter called as feature encoding. Okay, yes, some of you have already answered. Okay, just for others who are not aware of feature encoding, let me just give a quick understanding on feature encoding. Okay, feature encoding. Okay, first of all, if I go to my data is like this, right? These are my x variables: R&D spend, administration spend, marketing spend, and state, right? Now, ultimately, I have to pass this entire data to the model, right? What is a model? Model is nothing but a computer. Model is on computer, right? So computers only understand numbers. So can I directly pass this state to the machine learning model? No, it will not work. because the model will not be able to understand categorical data, right? So what we need to do is we need to always convert a categorical data into numerical data, and then only we can pass it to the machine learning model. Now this process is called as feature encoding. Now there are different types of encoder. People who are answering, can you tell me how many types of encoding techniques are available? I will wait for your answer. Write down as much encoding techniques as you know. Do not go to Google and search it out. With whatever knowledge you have, answer. Explicitly, there are no three or four, there are many, but give me the names. So, the first technique is label encoder. That's great. Label encoder. The second one is one hot encoder. The third technique is dummy encoder. There is another encoder called as binary encoder. There is another called as hash encoder, and multiple others. Again, on encoding techniques, I already have videos. See, I keep searching my own thing. So data encoding with techniques are already provided. 20 minutes video, you can go through it. Different type of encoding techniques are explained with coding part. Why it is showing in Hindi? That's, I don't know. So coding is also explained. Okay, how it is working. So we will be using one hot encoder and dummy encoder. Both are very similar to each other. How it works is, let's say you have a state column, right? So let's say I'm taking the first few records. Okay, let's say, okay, so what really happens is one hot encoding tells you to create as many columns as the number of total valid values that you have for that column. That means in the state column, if you have three values like New York, California, and Florida, then you have to create three columns: state underscore New York, state underscore California, state underscore Florida. Okay. Whenever you see New York, you put it as 1, others as 0. Whenever you see California, you put California as 1, others as 0. Whenever you see Florida, you put Florida as 1, others as 0. New York, New York 1, others 0. Florida, Florida 1, others 0. New York, California, Florida, New York. Now, these are your new features. You are basically converting this into three different features. This is called as one hot encoding. Dummy encoding is nothing but uh, dummy encoding is nothing but an upgraded version of one hot encoder. You in families there are some people, right? There is one guy who usually does the good thing. There is another person who tries to identify a small mistake in that particular person. In every family it happens, right? There is one person, let's say one son, or anybody, one person who does the work. He's very good at something, he does the work. There is another person who does not do anything. He only picks the work of that person and tries to identify, oh, you have done mistake here, so try to rectify it. So dummy encoder is that kind of person. So dummy encoder tells you that, boss, you have created three dummy columns, right? But do we actually need three dummy columns? Dummy encoder tells you that you do not need 3 dummy columns. In case you need to create n columns, instead you can create n minus 1. So in this case, you can arbitrarily delete one of these columns. Let's say I am deleting this. Why do we have to delete? Because this is a very obvious column. If this is 1, this is 0, obviously this will be 0. This is 0, this is 1, obviously this will be 0. If this is 0, this is 0, obviously this will be 1. So there is a concept of dummy trap. So dummy encoder works on this principle and tells you to only keep n minus 1 features. These are called as dummy variables. That's it. So that's dummy encoder. Label encoder basically tells you you don't have to do anything. Mark New York as 1, California as 2, Florida as 3. That's it. But is this the right approach? No. Because in this case, unnecessarily Florida has a higher number. So machine learning model will be considering Florida as a top priority thing, right? Because these are different numbers, not in the format of binary. So label encoding is usually not used for X variables. Rather, you can use it for Y variables. So let's say you have a column to predict whether the customer is cancerous or non-cancerous. You can convert them into zeros and ones using label encoder. That is fine, right? But label encoder is not recommended for X variables, especially when you have more than 2 valid values. Okay, coming back to the use case. So we were discussing the regression practicals. In this case, we have data like this. So you have data, you have different X variables, and you have profit, which is your Y variable. What you need to do is, first of all, you need to divide the data, training and test, right? You have to follow the same architecture like classification. If you need, you can do a feature scaling, then feature encoding, all these things, and then create a machine learning model. Let's say my first model is a linear regression model. So you pass the training data, and then on your testing data, you have your X test and you have your Y test. You only pass your X test data and get Y prediction. And then you compare your Y prediction with respect to Y test. Now let's say we'll take an example. Let's say there are 5 records, right? The actual values are 100, 150, 200, and something like that. Let's say 100, 120, 140, 150, and 80. These are my 5 records. And your predicted values are, let's say, 105, 125, 130, 148, 81. So in classification, what happens is you have classes, right? Cancerous, non-cancerous, cancerous, non-cancerous. What is the prediction? Cancerous, non-cancerous, cancerous, cancerous. It is easy to identify. Oh, one we are not able to predict, so the accuracy is 75%. But in this case, you cannot have a direct match, right? So here we use some metrics which is called as mean absolute error, mean squared error, root mean squared error, R2 square, adjusted R2 square, and so on. And if you are only doing a test with one model, you really cannot say whether this model is the best or not. Because let's say your MAE's value is 15, your MSE value is 100, let's say. You don't know, right? This is good or not. Nobody can tell whether this is good or not. Nobody can tell whether this is good or not. But if you have multiple models, You can calculate the MAE or MSE or RMSE for multiple models and then see whichever model has the lowest values. That model is the winner model, right? So, understood how we deal with regression problems? Okay, so evaluation part is secondary. Let's go ahead and implement a regression problem. So, I'll just try to read the data. 50 startups. Okay, data is fine. I'll just copy this. Done. Um, in the meanwhile, I can also push the data into the repository so that in case you want to download, you can download it and run the codes along with me if you want. Oh, yesterday's. It's okay. We'll do it later. So, 50 startups data is available here. Just download it. Going back to the code. So let's say I will import my libraries, import pandas as PD, import numpy as np, import matplotlib.pyplot as plt. So all these three libraries are done. Df is equals to pd.read csv, and then I'm reading my file. That's it. So I'll have a quick glance on my data. This is how my data looks like. I have R&D spend, I have administration, marketing spend, state, and profit. I'll quickly do a info on the data. So you can see there are 50 records and I don't have any null values. So everything is fine, right? Quickly, I will also go through the describe function so that I get to know the mathematical, statistical information. So R&D spend, mean the average is 73K. Okay, going forward, what I'm going to do is, um, let's say R&D spend. Okay, let's try to do one thing. Let's try to first do a simple linear regression problem. So I will divide the data. Let's say divide the data into x versus y, which is dependence versus independent variable, dependent and independent, not dependence. Okay, so let's say x is going to be my df and y is going to be. So I'm just taking my first column in x. So you can see in x I have these values: 165, 162, 153, and so on. 165, 162, 153. So I have only taken one column, right? Because we are doing SLR right now. So in practicals, I'm just doing SLR right now, right? I have taken my which column? R&D spend as my x variable and profit as my y variable. That's it. Okay. So eventually, I will be able to visualize the data. I will be able to visualize the best fit line. I will also be able to get the equation. No problem. But if you add more features, you will not be able to visualize because you are moving from two dimensional to n dimensional, right? And these are my x and y variables. Then comes training and test split. So here model selection, import train test split, um, x train x test y train y test is equals to train test split x comma y. Let's say my testing size is, let's say we have 50 records. Let's say we will give zero point 0.2. So what does this mean? This means I'm dividing my data into 80 is to 20 ratio. So my training data is 40 records and my testing data is 10 records. Okay, 80/20, right? So that's why I mentioned point 2. Okay. Now what we will do is, okay, now we will be calling the feature scaling. Feature scaling. So, however, feature scaling is not needed in just one feature, but it's okay to do feature scaling. So it's not a big deal. So let's say we will just implement it. It's a good practice to do feature scaling. But remember, this is a simple linear regression problem with just one feature, right? So feature scaling is not mandatory here. Okay. So I'm importing my standard scaler. So I will initiate my standard scaler, and then I will call my xtrain is equals to sc dot fit transform xtrain xtest is sc dot transform xtest. Done. So I have my okay, reshape your data either using array dot reshape. Okay, so basically it is expecting a two-dimensional array, but we have one dimensional. So I will just reshape the x variables. So let's say x train is equal to x train. See, already solution is here. It is telling you to do the reshape. So you can copy this and do the same for your training and test. Or if you are using this thing, ChatGPT, you can ask ChatGPT also, right? Sorry. X underscore test, X underscore train. Got it? Done. I will come back to this code and I will change it. Done. So my feature scaling is done. So my reshaping is done and feature scaling is done. Basically, it added one more layer. That's it, right? It was one dimensional, it became two dimensional. That's it. That's a requirement. Now we will be creating the linear regression model. So linear regression model is again linear regression sklearn. It is present inside sklearn dot linear model. You can see sklearn dot linear model. So I'll just copy paste it from sklearn dot linear model, import linear regression. Here I will call my regressor is equals to linear regression, and then regressor. I will keep it simple, okay? I don't want to make it too big. Regressor dot fit. I'm just doing training data. Okay, my regressor is ready. Now I will be doing predictions. So my ypred is regression dot predict. I will pass my testing data, and then you can check your predicted data with your testing data. So this is how you can see the predictions are not bad, not bad, not good as well, but it's okay. Now if you want to plot it, you can simply plot this with this. How to plotting plotting your, what do you say, predicted versus actual test data. So plt dot plot y test, plt dot plot y pred, plt dot show, and here let's say I will give a color. Let's say I will make it blue. Label I will give as test. Same I will do here. Color equals to red. Label is equals to predictions. Hopefully this will work. And you can see this is how the test versus the predicted value is. It's very close. It's a good model that we have created. So just with one feature, we are able to create a model. Now if I go back to Miro board, so what we did, we had the data. I will again draw the architecture. See, the way I am doing it, you have to also do it multiple times. Whenever you are going through my classes or videos, you have to do what I am doing. If you do this thing multiple times, automatically you will remember. Right? That is the art of writing. There is no such shortcut to remember anything, right? From our school days, we know this. If you write a certain topic for 5 6 times, you will automatically remember. So do this again and again and you will understand. So what we did was, we had the data, right? First of all, what we did, we divided the data. We did some EDA. So yeah, write down this way. We do some EDA, simple EDA, and then we divided the data into X and Y, and then X train and Y train. So I divided the data into training data and testing data. X train, Y train, X test, Y test. Okay. Then what we did, okay, reshaping is not a major thing that we did. The reason why we did reshaping is, your standard scaler was expecting a two-dimensional object. Even if you are passing one variable, it has to be passed in a two-dimensional array space. So that was the requirement. So we converted it into a two-dimensional array just by doing a reshape. Okay. Same in deep learning also, when you go for CNN models or ANN models or RNN models, right? There also you have to reshape your data. Let's say you have an image which is a two-dimensional image, or it's a grayscale image, two dimensions. You have to convert it into three dimensions in order to pass the data to the architecture. So you cannot really, you know, there is no other way. You have to reshape so that your existing data is fitting to the architecture, to the model's expectations, right? So here standard scaler was expecting us to have two dimensional space, so we did that, right? So coming back to the Miro board, I'm not mentioning the reshaping thing. After reshaping, what we did was, we did the feature scaling. So we did feature scaling. So eventually after feature scaling, we have the new X train dash, Y train, and X test dash, and Y test. Y is not changing, right? Because in feature scaling, we are majorly passing the X data, right? Because X data needs to be scaled, not Y. So Y is not changing. X is simple. Okay. After feature scaling, what we have done is, we have called the linear regression model. So you have created the linear regression model. You passed these two data to the model. Now the model is ready, and then you fit the data with training data, and then you are predicting on the testing data. So while prediction, you are only passing the X test data, and then you are doing the Y pred, and then you are comparing this with this. As simple as that, right? So let's do the comparison part. I'll try to answer your questions in the break time. So meanwhile, I'm not looking at the chat box very actively. I saw somebody was asking something. I'll answer it later. Okay. So regression metrics. So let's say from sklearn.metrics, import mean absolute error. So mean absolute error, let's say I will pass my testing data and my prediction data. What is my mean absolute error? It is 6424. Okay. Now let's say, for example, I'm going back to the data. Okay. Let's say my requirement is, uh, I'm inserting one record here. Okay. Forget about these things. Okay. Let's say this was your data. My question now is, again, these three columns also can be ignored, right? Because they are not into consideration right now. We have just used one column and we're predicting. My question is, what will be the profit if my R&D spend is 135k? That is the question. So we need to predict this part, right? So how will we do practically? Predicting for a new record. So let's say I will write it down. The data is 135,000. What I need to do? Ah, What I need to do first, I need to store it in a data frame. So let's say pd.data frame. I will store my data. Then I will also convert this into. I will have to transform it, right? Because in your original data also we transformed. We did standard scaling, right? So we are doing the same thing. And then after that you can print the new df, and the output is 1 point. Sorry, my bad. After transformation um, we need to call the regressor and do the prediction on the new data and then print the this part. Sorry, my bad. So the output is 165627. So that is my prediction. So based on this model, we are predicting that for this R&D spend, the profit will be this. Now let's try to do one more thing. Let's try to take a very small number. Let's say 35,000. What will be the profit? The profit is low, 78,000. So for 35,000, the profit is around 78,156, which means when the R&D spend is decreasing, my profit is also decreasing. Last try, I will do a very high R&D spend, and you can see the profit is massive, right? That is how you do the prediction part. Got it? So now, what we will do is we will do the MLR part, multiple linear regression. I'll make it bold so that it is visible properly. Here I will change it to uh, simple linear regression. Okay, here I'm going for multiple linear regression. So far with simple linear regression, any doubts? There should not be any doubt. I'm assuming I'm going very slow. Let me cover multiple linear regression now. Now for multiple linear regression, I need to take all the columns, right? R&D spend, this and this, right? And then on this column, I need to do the encoding, like feature encoding, right? So what I will do is, I already have my original data frame, right? I will try to create a dummies on top of it. So df dummies equals to pd.get dummies. I will pass df. I will do drop first equals to true. So what I am doing here is try to understand this piece of code. I am doing the get dummies. Get dummies works only on categorical data. So I'm passing df. Ultimately, state column will be converted into multiple columns. State something, state something, state something, right? And then I'm dropping one of them, dropping the first one. So now if you look at the latest data, it will have R&D spend, administration, all these things were already there. Now you have state Florida and state New York. State California is not there because it has been dropped. Okay, you can drop any of them, Florida, New York, or California, doesn't matter. Okay, false true basically is a boolean value, but some of you might see 0 and 1. So you see 0 and 1 or false or true, doesn't matter, both are same. Okay, now after your get dummies is done, what I will do is I will divide the data into training and test. So dividing the data. Before doing training and test, I need to divide it in x and y first. So I will write it down as xmlr is nothing but df dummies. I will just drop my profit column from which axis, from my first axis, and then ymlr is df underscore dummies. I'm just taking the profit column. If you look at xmlr, it looks like this, right? Except profit, you have all the columns, right? So I'm deleting this. Now I will do the training and test split. Training test split. We will copy paste the code from the above code. Where is that? Where is that? Okay. So here I am passing it as xtrain. So let me just give new variable names just for avoiding the confusion. Xtrain mlr. I'm just adding mlr. Now this is x underscore mlr. This is y underscore mlr. Done. Everything is fine. Now I'm doing the standard scaler. So I will again copy paste this code, bring it down. Now here, um, let's say I will make it as xtrain mlr and xtest mlr. Okay, so my standard scaler is ready. Now I will create the mlr model from sklearn.linear model import linear regression. So there is no such other algorithm called as multiple linear regression. There is just linear regression. If you pass one column, it becomes simple. If you pass multi, it become multiple. As simple as that. So I will write it down as regressor 2. I will create this linear regression model, and then regressor 2.fit on top of my MLR data, ytrain MLR. All good. Now I will do the prediction part. Ypred2 is equals to regress2 dot predict on top of my test MLR. My predictions are done. Now I will again copy paste the this thing, my mean absolute error. Remember, with one feature the absolute error was 6424, right? Now with multiple features, what is the 35,400? So here it was 6,400. Now it is 34,000, 35,400. That means the error value has increased. That means there is definitely a particular column that is problematic. Okay, so which there are some statistical methods using which you can identify which exactly are those columns that are problematic, because right now what we have is you have multiple features, right? You have x1, you have x2, you have x3, you have x4, you have x5. How many features are there? 1 2 3 and then 4 5 features. Now in the simple linear regression problem we only took this, but now we are taking all, right? Out of this all, there may be some features that are not helping your model, because of which your predictions are not proper, right? Let's say x3 is x3 and x4, these two are not good. Eventually you need to cancel them to find the optimum model. But how do we get rid of these functions? Now there are some statistical tests that we usually do, and based on those statistical tests, we kind of identify which features are not important. That is basically considered as part of feature selection process. There is a recursive backward elimination process, there is a forward selection process. Based on those processes we identify which feature is important, which is not important. Okay, apart from that, you can also do one more thing. take all your features and try to find the correlation with respect to the y variable. That can also be done. Sorry, y test MLR. That's correct. My bad then. No, oh, yeah. My bad, my bad. But it it that okay. The error rate is not that much, but still it is high. Thanks for pointing it out. I forgot the variable name. Anyways, so but the eventually that's the same thing, right? With just x1, your model was giving somewhere around 6,400 of MAE, right? When you are having x1, x2, x3, x4, and x5, you are getting somewhere around how much? Getting somewhere around 8,700, right? MAE. Now, is this the optimum value? No, we don't know. Obviously, x1 individually is better than these five features, right? Yeah, I changed the code, right? But out of these five features, there could be a scenario like x1, x2, and x5 combined together might give you even a lower MAE. In that case, these three features are the best features, right? That can be done. So using feature selection and recursive feature elimination, we can do that. So, but I think you understood what MLR is. We just have 1 hour for clustering. Let's go for a short break, 5 minutes break, and then I'll quickly come back. And actually, feature selection, backward feature elimination takes a lot of time to explain. That's why I'll not be able to explain. Um, we will wind up regression here itself. Yeah, but I'll tell you another easy way in order to identify which particular features are going to be important and which are not using correlation function. It's not the most optimum technique, but yeah, you can use correlation function as well. So you need to find all the features correlation with respect to the y variable. Let's go for a 5 minutes break, and then I'll come back and I'll proceed with the rest of the topics. In the meanwhile, let me check all the comments. You can go for break, guys. In my local machine, it says 11:28. So in Indian time, it must be around 8:58. Be back by 9:05, and we will proceed. Okay. Bashir, good topic. That's what I told you. When you have multiple features, let's say you have five features in this case, right? We don't know how many features are best features as of now, right? So there are some feature selection processes. One of them is called as forward feature selection process, backward feature elimination process. Multiple processes there. What we do is we try to do a hit and trial on multiple things. We first run with five features. Then, using a statistical test, we identify which feature is the least important feature. Then we remove them. Let's say x3 is the least important. Then we remove them and do x1, x2, x4, x5, and then run the code and we calculate the MAE. Then we go for the statistical test, and that's a iterative process that we do. Okay, I'll be back in 5 minutes. Okay, I'll take your questions after that. Okay, I'm back. Let me see the comments. Can I even use machine learning in such a case? Wait, let me go through your entire question, Bashir. Um, can I even use? Let me check out your previous comments. We can use heat map to check. Yes, yes, we can use heat map to check. How do you decide dependent features? My question is that I have a wind data. Oh, I'm getting confused with Mohammed Bukar. Let me go through your good day. This is my first understanding what machine learning is, and I've been following your class. Thank you. My question is that I have a wind data for about 3 years in my place. So it seems I can use machine learning to make prediction. The data are from January to December. What is going to be my Y and X? Okay, Mohammed Bukar, the problem statement that you told me is not a regression problem. It's a time series forecasting problem. Okay, because you have a date column. When you have a date column in a regression problem, that becomes a time series forecasting problem. So that's why I told you when I started with regression, I told you, right? I usually deprioritize regression topics because in industry level problems we do not have a regression problem. Trust me, I have been working in this industry since 8 years, since 13 years, but in the space of data 8 years. I have never done a single regression problem in my entire career. In fact, there is no regression problem in this entire world, because whenever you are analyzing something, if you start analyzing with respect to date column, right, the problem shifts from a regression problem to a time series problem. And every industry has date column, right? You are capturing any kind of data, every company captures the date as well, the time column. And when you have a time column, it becomes a time series forecasting problem. So you can have some algorithms like a Facebook Prophet or Arima or LSTMs to solve these kind of things. That's why I usually tell my students, regression topics, whatever I'm teaching, just study that, that's it. Apart from that, they do not have any practical use cases. Okay. um I cannot show you feature selection and feature backward feature elimination because that will take me a lot of time. In case you are interested to learn about individually about these things, what backward elimination is and all those things, you can enroll for my program. It's not like I'm pitching my program, but the thing is, I'm going to do a 12 hours lecture on machine learning, so I don't have time for feature selection processes. Okay, but one thing I can tell you is using correlation, you can actually identify which features are important, which are not. So let's say you want to find the correlation matrix. So df, we have df underscore dummies, right? Df dummies dot correlation function with respect to profit. If I do that, so you can see administration has a very, very low correlation. State Florida and state New York, they have even low correlation. So what I'll do is I'll try to I'll try to remove these columns and try to run through another model. Okay, so let's say multiple linear regression, removing the unwanted columns. So this is also like a feature selection process, because using correlation we are able to get administration has a very low correlation, state Florida and state New York has a very low correlation. Okay, so I'm again going back to my df dummies, right? I will, what I will do is I will again go back to my X and Y selection. So this part, what I will do is, um, instead of dropping profit, I will be dropping multiple columns like administration and state Florida and state New York. So I should have done XMLR2. Okay, I will do this. Now my XMLR2 is only two features, which is my R&D spend and marketing spend. Got it? Now I'll again follow the same steps. Let me write down these codes. XMLR2, 2, 2, 2, XMLR2, YMLR2. Got it? After training and test plate, I'm going for the standardization part. After standardization part, I'm going for the model part. And after the model part, I'm going for the regression part. Sorry, the prediction part. And then I'm going for the metrics part. So code I have copy pasted. I ran code through here. Just changing this to MLR2, 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 MLR2. Whenever I'm doing a mistake, let me know. Okay. Uh, Done. And then regression 3, MLR2, MLR2. Now prediction 3, regression 3, MLR2, and then YPRED 3, MLR2. So 7037. Now only with X1, so only with R&D spend. It was R&D spend, right? Yeah, only with R&D spend, we were getting somewhere around 6,400 MAE. Now with R&D spend and what are the two features? R&D spend and marketing spend. With R&D spend and marketing spend, R&D spend and marketing spend, I'm getting around 7,000. And with all the features, I'm getting around 8,700. So definitely the lowest is still here, right? So simple linear regression is still the best for now. But what I will do is I'll again go back to my correlation test. If you look at the correlation test, you can see the highest is with profit, R&D spend. Marketing spend is still the second highest. So I can easily conclude that R&D spend is the topmost feature, and in that I'm getting the lowest MAE. So this problem is solved here only. Okay, so that brings us to an end to regression. Now we will be jumping into clustering. Okay, there is a question from Muhammad Bukar. Can I use? Okay, please tell me a difference between machine learning and time series analysis and forecasting. So time series analysis and forecasting is a part of machine learning. It's a statistical technique. It's a part of machine learning. But how is it different from regression? In regression, you don't have a date column. In time series data, you have a date column. Time series is going to be taught in the next Saturday class, requesting you to join it on time. So your doubts on time series will be covered there. Okay, do not worry. So time series we are covering next class. Got it? Let's jump into the next topic, which is clustering. One second. Got it. Okay, let's move into clustering. I need to. Okay, now it is better. So, what is clustering? First of all, clustering goes back, going back to the basics. Clustering is part of unsupervised learning problem, right? Where you don't know what needs to be done, right? Let's say you get a bunch of data, bunch of customer data, and your manager asks you to create different segments. So his question is very simple. Can you tell me which customers are similar in nature? That is his question. So what you need to do is you need to find different clusters, right? And if different customers are in this cluster, which means all of them are similar in nature. All of them are similar in nature. All of them are similar in nature. All of them are similar in nature, right? So that is where clustering comes into picture. Did we finish supervised learning? Yes. Classification and regression is finished. Time series forecasting is also a part of supervised learning, but time series is a separate module. That's why I'm going to teach time series in the next class. Okay. For now, we will be covering clustering. Okay. What are some real time examples of clustering? There are many real time examples. Okay, I can talk about hundreds and hundreds of use cases. First is customer segmentation. That means you need to segment different customers. How many segments we don't know. That is why it is part of unsupervised problem, right? Whether it is 5 segments, 10 segments, or 2 segments, we don't know, right? Similarly, there are other examples also. Fraud detection or fraud analysis. Fraud analysis. You have bunch of frauds, but you don't know. So, okay, fraud analysis or fraud detection is considered as part of both supervised and unsupervised. I will tell you why I am explaining this in unsupervised. You must be thinking fraud detection is simple, right? Some records are fraud, some are not fraud. So it is a classification problem. So why is it studied under unsupervised problem? I will tell you. Don't worry. What are some other use cases? There are many. Market segmentation, news segmentation, any kind of segmentation topic, any kind of clustering creation. Let's say movies clustering, basically used in Netflix. When you create your data, right? You have different type of movies, right? You have to cluster together based on their genres, based on their customer liking and all those things, right? So those kind of scenarios you use clustering. So many use cases are there for clustering. Okay. Personally, I will be picking this because if you understand this, all your doubts will be cleared. Why I am going to pick this is because it is a real life scenario. Okay. In one of my previous companies, I was given this problem statement. My so basically, I did not had a manager. I was the only guy in the company who was working in data science. So I was told that I need to do some sort of fraud detection. Okay. So the problem statement is clear. I need to identify frauds, right? But the data that I got, it did not had a label. So there was no column that says whether this is fraud or not fraud, fraud or not fraud. So this column was not there. I only had records, transaction ID, messaging ID, message code, all different features were there, but there was no identifier whether this record is fraudulent record or not fraudulent record. Okay. If you have a label fraud and not fraud, that makes it a clear scenario for classification problem, right? you can easily call your classifiers and create it. But in my case, there was no label. So what I did was, first of all, I took all of this data and I tried to create clustering. So I created some clusters. Let's say I got 5 clusters, right? Then what I did was, I asked my cybersecurity expert, boss, in your original data, let's say there are 1 million records, right? 1 million records, nobody can go through each and every record and write it as fraud or not fraud, right? It's a tedious task. Nobody will do that. But when I did clustering, I got the lowest cluster. Let's say lowest cluster was around 10,000 records. Now I go and talk to my cybersecurity expert, boss, you don't have 1 million records, you just have 10,000 records. Out of this 10,000 records, can you please go through and label them as fraud and not fraud? Now, this cybersecurity expert have to do it. They don't have a choice. Once they do this, what I will do is, now I can use this as a training data. And then I can call a classification model and train it. After my model is trained, I can use the second smallest cluster for testing. And out of this, let's say this is 50k records. Out of this 50k records, let's say my model predicts 1000 as frauds. Then I can again go back and ask the cybersecurity expert, boss, can you validate these 1000 records whether they are fraud or not? And that's how you can convert your clustering problem into a supervised problem. Okay, but this part is the critical part, identifying the number of clusters, because nobody will tell you how many clusters to create. If your manager asks you to create customer segmentation, your manager himself does not know how many segments do you have to create, 3 segments, 5 segments, or 10 segments. So in these kind of problems, clustering comes as a rescue. The topmost clustering algorithm is called as k-means clustering. Another clustering is hierarchical clustering. Another clustering is mean shift clustering. Another clustering is called as DB scan clustering. K means clustering, one of the most important clustering algorithms. Okay, so let me open the document. I'll go to clustering. Yeah. So clustering methods are a machine learning technique that involves. Anybody has any questions? Write it down. I will pick your questions at the end of the session. Okay. Um, Clustering methods are a machine learning technique that involves the grouping of data points. These methods are used to find similarity as well as the relationship patterns among data samples and then cluster those samples into groups having similarity based on features. Okay. What are the different types of clustering algorithms? K-means, hierarchical clustering, and mean shift. So let's try to go through K-means clustering. If you are following me on LinkedIn, you will find the PDF. The PDF is already shared on LinkedIn. If not, I can not if not, it is already shared. I can also share it in the GitHub repository. Those who have not liked the stream, 15, 18 of you are watching. Go ahead and like the stream. Go, go, go. Where is that, man? One second. Where is my banners? Yeah. Please like, share, and subscribe the channel. In case you're interested in the end-to-end AI program that I have recently launched, feel free to reach me out on WhatsApp, and I will be able to guide you. Okay. That's a big file, larger than 25 MB. It's a 31 MB file. Let me just try to copy this again and try to zip it up. No, zip is not working. So I'll have to push it through my. I directly cannot upload it. I'll push it later. Um, so do not worry about it. But yeah, as I told you, if you are following me on LinkedIn, you will be able to download the file. I've just posted it today itself. Okay, so you can download it there. Coming back to the k-means clustering. So how do we identify the k value? First of all, what is k-means clustering? K-means clustering is a clustering approach where you have to identify the number of clusters based on this algorithm. What is k? K is the number of clusters. Number of clusters. How do we identify k value? So there is a statistical method based on which we can identify the k value. Okay. First of all, let me take an example and explain you what exactly is k-means clustering. Okay. Again, taking the example of a two-dimensional graph. Let's say you have multiple data points. Okay. Okay, these are the these are the multiple data points, 336 for 10, 13 data points. Maybe I'll make it 15. Okay. Now this is my x, this is my y. Okay. First of all, try to understand what is WCSS. WCSS means within the cluster sum of square. Within the cluster sum of square. That is basically your WCSS. Okay. Now using WCSS, we will have to identify the k value, the best possible value. Okay. Now before that, let me also write down the formula of WCSS. It's not that complicated. Theoretically, I will explain you. WCSS given k is nothing but summation of I is equals to 1 to k. um, you can write it down as I forgot. Wait, it's basically x minus the mean value. Okay. I exactly don't remember this thing, but I will write down in the layman's term. Basically, we need to find the distance between the data point. Let's say I will write it down as xi and the centroid square. So what is this part? This part is the distance between the input data and the ck. Ck means centroid. Okay. Now assuming this as your data, right? Where will be the centroid? Centroid is the center location. Let's say the center location is here. Okay. So let's say there are first in the first case, let's say there is one centroid. There is one cluster. Okay. So for one cluster, let's say I will draw this cluster like this. Can I copy this part? Wait, let me. How do I select this? No, not this one. Ah, I can select like this, right? So I'll have to draw multiple graphs. Okay, so I just drew multiple graphs. Let me just erase these things. Okay, um, the first case is, let's say I have one cluster. One cluster will look like this. In this cluster, this is your centroid. So what will be your WCSS value? The WCSS value will be nothing but distance between the centroid with all of these data points and the square object, right? So the WCSS will be a very high number, right? Now let's say you move from one cluster to two cluster. So let's say in case of two clusters, let's say this becomes one cluster and this becomes one cluster. Let's say. So for this cluster, let's say your centroid will be here. For this cluster, the centroid will be here, right? So for WCSS 1, the value is very high. For WCSS 2, in this case, what will be the total WCSS? You have to find the distance between all of these data points and all of these. Tell me one thing, will WCSS 1 will be greater or 2 will be greater? Think about it and tell me. Think about it and tell me which one will be greater. Can you tell me the sigmoid function? What is the sigmoid function? This is summation. There is no sigmoid function here. I'm simply finding the distance between your data points and your centroid. I'm repeating once again. All your data points, you have one centroid here, right? Because you have one cluster. Here you have two clusters, C1 and C2. Which WCSS will be greater? How both will be same, Karthi? Let's say for this particular data point, the distance is huge, right? In this case, for this particular data point, the distance is low, right? So how will both will be same? In the first case, you have one centroid. In the second case, you have two centroids because there are two clusters. How will both be same? What about others? WCSS 1 will be greater or WCSS 2? WCSS 1 will be greater, right? WCSS 2 will be smaller. So when you go to the next one, let's say here these three becomes three clusters. This will be your first centroid, second centroid, and third centroid. Now what will be the total distance? It will be less, right? So when you have four clusters, so ultimately dot 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 when you have n number of clusters, your WCSS goes down. So if you draw a graph in your x-axis, you have the number of clusters. For one cluster, the WCSS is very high. For two clusters, the WCSS decreases, 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 and for n clusters, the WCSS is almost zero. Now, this is also called as elbow method because distance is decreasing, right? When the clusters are increasing, distances are decreasing, right? So this is also called as elbow method. So this basically tells you what should be your optimum k value. How? Whenever this graph forms a elbow, let's say somewhere here at k is equals to 3, the graph forms an elbow. So this is your most optimum solution. And that is all about your k-means clustering. Similarly, we also have hierarchical clustering. If you go through the hierarchical clustering, the pseudocode is here. Okay. So let's say in hierarchical clustering, let's say I will take a simple example. Let's say P1, P2, let's say P4, let's say P3, P5, P6, something like this, right? There are 6 data points. Somebody, if they see, obviously they will think 2 clusters are optimum, right? But using hierarchical clustering algorithm, how do we identify the number of clusters? Hierarchical clustering tells you first make each data point a single cluster. So first each data point is a single cluster. Take 2 closest data points and make one cluster. So which is having the lowest distance? Let's say P3 and P6 is having the lowest distance. So they become one cluster. So in the next step, okay. So next step, this becomes a cluster. So how many clusters do we have? 1, 2, 3, 4 and 5. Next step is take 2 closest clusters and make one. So let's say now in this cluster, the centroid is here, okay? Let's say the next step, these two becomes closest. So this becomes a cluster. And this process goes on till there is one cluster, right? So let's say the next step is, so here this two becomes one cluster. Here this three becomes one cluster. Now they become one cluster, and now these two become one cluster. Here ultimately these two becomes one cluster, and here ultimately everything becomes one cluster, right? So that is what hierarchical clustering is telling, right? In first of all, what we need to do is we need to find the 2 closest points and make one cluster, and then it goes on till we have one cluster. And after that, what we will do is we will try to use these uh, distances as a base, and we will try to draw the graph. So let's say there are 6 points, right? So let's say P1, P2, P3. As P6 became first cluster, I'm just making it P6 here, just for our ease of understanding. Um, I'm shifting the points a little bit. I'll make it P4 here, P3, P6, and P5. Okay, because if I make it 1, 2, 3, 4, 5, 6, it will be clumsy. You will not be able to understand. In the first step, which 2 data points were the closest? Can somebody tell me in the chat box? In the This is step number 1. This is step number 2. This is step number 3. This is step number 4, and this is step number 5. In the very first step, which 2 data points were the closest? P3 and P6 were the closest, right? That means the distance between P3 and P6 are the smallest, right? So P3, so in my y-axis is my distance. Okay. So P3 and P6 form one cluster. The second step, P3, P6 together became a cluster with P5, right? So definitely, let's say I draw my P5 here, P3 and P6 here. That means this distance is greater than this distance, right? So they two become a cluster. In the next step, P1 and P2 are closest. So definitely this distance, let's say D3, is greater than D1 and is also greater than D2, right? So P1 and P2 distance will be greater than this distance, right? So I made it here. Okay. And lastly, P1 and P2 become cluster with P4. So this distance will be somewhere here. And eventually they all become a cluster. So this is called as a dendrogram. Dendrogram. Okay. Fine. Dendrogram is fine. How do we find the optimum clusters? We need to find all the vertical uh, lines. So let's say this is line 1, line 2, line 3, line 4, line 5, line 6, line 7, line 8, line 9, line 10. Okay. We need to reject those lines which are getting dissected by the horizontal ones. Now let's say line number 4 is getting dissected, so 4 is cancelled. Same, 6 and 5 is also cancelled, right? Um, number 10 is also cancelled. 8 is not cancelled. Line number 2 is also cancelled. Line number 4 is also cancelled, right? So how many lines are remaining right now? Line number 1, line number 3, line number 8. Out of these 3 lines, we need to find which line is the largest. Potentially, line 1 will be the largest. Now, on top of the largest line, if you dissect, you have to see how many dissections it is forming. It is forming 1 and 2, which makes this as one cluster and this as one cluster. So your final output is this. So this becomes one cluster, this becomes one cluster. So that is how your hierarchical clustering works internally. Externally, you just have to call sklearn library and your work is done. It's not that difficult. So let us go through a simple, let me download this code. Let us go through a simple clustering practicals. And in the meanwhile, let me also save this code here. And I will also upload this file, regression. Okay. Now, okay. I will create a new notebook for my clustering. It's a very important use case. If I'm not able to complete in 20 minutes, we'll be able to complete. Let's be positive. So let me write it down as ML clustering. So I will take an example. So there is a data set. Customer data, where is that? This one, download. Huh? Where did it download? Customer data. So I'll use this data. Let me upload this file in the GitHub. Actually, I'll make a data folder so that it looks beautiful. Okay, anyways, I'll be using that file. So I'll take that file, customer data. I'll show you the data. Okay, this is how the data is. Now, there are multiple customer information here. We have balance frequency, purchases, multiple features are there, right? And your manager has asked you to do some segmentation. There is no y variable here, right? It's simply a data set where no y variable is here. So what will we do here? Let's try to um, use this data set to create a clustering problem. So let's say, first of all, I will import all my libraries, pandas spd. Uh, when I used to teach machine learning live classes, I used to have more students than YouTube live. That's horrible. People say yes, yes, yes in the voting, they don't join. Actually, the thing is, people don't really care about free materials and free videos. People only, it's a normal human tendency. They, everybody just gets excited by seeing free keyword. So initially, everybody says yes, but nobody joins the call. That is the worst thing about teaching, and that is one of the reasons I stopped doing live sessions. I used to do 2 years back, and eventually not much people join the classes. Why it is not working? Let me refresh. Sorry, Bashir, if your clustering colors red and blue, if distance between red and blue is less, there is a chance that they can be in one cluster. Come again. Not able to understand. If your clustering colors red and blue, if distance between red and blue is less. I did not understand your problem. Okay, I'm just copying this. My data frame is ready, so I will move on with the code. Um, Basic things I'm doing: head, describe, info, all these things are basic things. So first of all, let me just drop my customer ID because that is not needed. And before that, let me also drop all the null values if I have any. So I'm dropping my customer ID as well. Access equals to 1, in place equals to true. Done. Now if I go back and check my data frame, that's how my data frame looks like. Fine. Um, First of all, if you want to check all the graphs for all of these features, you can do that. Um, let's see, how many columns do we have? 1, 2, 3, 4, 5, 6. So df dot shape is giving me 17 columns. Okay, let's say we'll try to plot this graph for num in range of 0, 17. I'll use a subplot here. Um, subplot. Call equals to df dot columns num, then sns dot test plot df of column. Let's say I don't want to use subplot. Only tenure is plotted. Why? Dist plot is deprecated. Fine, doesn't really matter. I can use this plot. Okay, anyways, so you are able to see all the distribution of the data. See, this is not something that is in the agenda. This is something like if you want to do some EDA activities, you want to check how the distribution is and all those things, you can do analyze your data with respect to your visual representation. You can analyze it, so you can perform your EDA, right? I'm not concerned about EDA, so I will not do the EDA right now. So I'll move ahead with the other things. Okay, so the other things is I'll quickly just do a heat map quickly. So let's say I'm doing a heat map on my entire data frame. So I'm doing a correlation map. C map, I will just use some random C maps, whatever I remember. Annotation I want to use. PLT dot title I will keep as heat map. Font size, let's say 30 or 20. Font size equals to 20. PLT is not defined. I defined it, right? As PLT. So this is my heat map. Wow, it looks horrible. Let's say I will try to make it 30. Figure size, actually I need to change. Figure size, figure size, figure size. My bad. It's very difficult to remember all these things. Change the figure size of this heat map. Figure size. Okay, PLT dot figure size. Cool. No issues. I will add it separately. And then my heat map should be like this. Okay, so this basically tells you how the correlation value is with respect to each other, right? So if you see higher in the grading, like yellowish, that means, let's say, purchases frequency has a direct correlation with purchases installment frequency, and so on, right? So that's how you calculate the correlation, right? Anything else? Anything else to see from this graph? Purchases, yeah, 0.92 here. This is a good one. One of purchases and purchases have a very high correlation, right? Which basically means either, I mean, they are very highly correlated. When purchases is increasing, the one of purchase values is also increasing, right? So this is the analysis part. Now what we will do is we will quickly jump into the clustering part. So before clustering, I will also be doing standardization. So let's say feature scaling from sklearn dot pre-processing import standard scaler. For clustering, I will tell you one thing, that I actually have a very good case study in my channel already. Okay, in case you are interested in this case study, you can go through this. This is a live, it's a real-time project, market segmentation project. Just search market segmentation and my name, you will be able to get this project. Here I have explained everything, the use case, the clustering technique. I have taken the clustering technique and converted it into clusters and given them some tags, created classification models. So it's an end-to-end project. So you can watch out that, right? uh, because I cannot cover that. So coming back to my code, I will be back to the code. So I'm starting with the feature scaling part, calling the standard scaler. So let's say sc standard scaler, scdf is equals to sc dot fit transform. I am passing the entire data frame. Okay, now here I don't have testing and training, right? Because here there is no y variable. So I need not have to divide my data into training and test. So I'm directly doing the fit and transform. So first of all, I will be calling the elbow method. What is elbow method? A repetition of what I explained you, right? In the k-means clustering. Guys, before one more thing I forgot is, go to the video's description. You will be able to find the link of this Miro board. You can refer to this diagram later. Okay, so this part, right, this is the elbow method. We have to find the WCSS with respect to all the cluster numbers. So this is what I will be doing right now, implementing the elbow method. Elbow method from sklearn.cluster. Honestly speaking, I don't remember the code. K means WCSS. Let's say I'm taking a blank thing. Let's say I'm taking I in range of 0 comma 11. Let's say I will take till 10 clusters. Okay, sorry, not 0, 1 till 11. For 10 clusters, let's say I will pass K means. I'll be passing. Okay, thankfully, n clusters. Let's say n clusters is nothing but my I. Init function, I remember it should be k means plus or k means plus plus. This is the algorithm that we are using. Max iteration, let's say 300. Oh, it's okay. I don't want to define. It's taking the default values. Um, anything else? Anything else? Verbose, random state, not required. I think that's it. And then I will call my k-means.fit method and I will pass my scdf, and then I will append my WCSS in the k-means dot inertia. K-means dot inertia, yes. And then plt dot plot range of 1 comma 11 WCSS. Plt dot title, let's say I'll give elbow method. Plt dot x label, I'll give clusters. Plt dot y label, I'll give my WCSS. Plt dot show. Hopefully this code should work. My voice is breaking. Should not. Is it breaking now? No, right? Okay. So this is my elbow method. Now, what is an elbow? Elbow is simply like this, right? Elbow. So basically, whenever this junction, you have to find this junction. This is an elbow, right? Now, in this case, it is not forming an elbow, but what I will what I will take is somewhere here, right? Somewhere here or somewhere here. Maybe you can take some k value. Let's say 4 or 6. But again, k value is not something that is final. K value is a potential number of clusters. That is why it is unsupervised learning problem, right? Because you cannot identify the exact k value. From this graph, it seems like 4 or 6. So I will do a hit and trial on 4, 5, 6, 7, all of these nearby k numbers. Okay. So in this case, I will take 5 as a sweet spot. And then what I will do is I will call my k-means clustering. So k-means is equals to k-means and clusters. I want to take 5. Random state, let it be init function, let it be k-means plus plus. That's it. So y k-means equals to k-means dot fit predict on my x variable. Sorry, my x is not defined, right? um, Wait. We have not divided data into x and y, right? uh, there should not be an x and y, so how can we do the predict? Let me figure out 1 second. No, basically my voice is not fumbling. Sometimes I talk to myself. That's why you must be thinking that something is going on. Mm, 1 second. Clustering. K means clustering. Okay. So basically, CDF. Then let's say I copy this to CDF. Okay, what is X here? X is nothing but all the features. And then here, it's passing the X, which is all the features. And here, what is my SCDF? 1 second, I'm just getting confused. So SCDF is all my features, right? Yeah, that's correct. So this is my SCDF. Let's say my X is my SCDF. And then instead of this, if I do this, it should work. Yeah. So let me just change this code because we have 5 clusters. So we'll name it this. The thing is where we have multiple features. Balance this thing, this thing, this thing. Standardization is here, and then we are converting it into k-means. K-means clustering. This is fine. Elbow is got. Then we need to do the prediction on top of. So here, if you do k-means, and then here you are basically taking the hmm. So in this case, actually the data is quite scattered. That's why it's not able to properly show you this thing. I'll take this one as an example. Let me explain you this one, okay? In this case, what's happening is the data is quite scattered. As per the algorithm, you are getting these clusters, but again, as I told you, these clusters, I have multiple features in my data set, multiple features. Based on multiple features, my k-means clustering algorithm is created, right? But I'm visualizing only on two features. That's why based on these two features, the data points are scattered. So probably I'll have to fix this part, because it's not the right way of representing the data or visualizing the data, because we have multiple features, right? Or if we had two features only, then we can easily show you the data, right? But it's so let me just take an easier example. I'll come back on this example in the next class, okay? The very first thing that we will do is this use case, but I don't want to waste the time in the call right now. So I'll pause this use case here itself. I'll go through this easier one. This is an easier example, and you will be able to understand this use case very easily. Let's say I have this small data. Um, Let me also take this data, mall data. So if you look at this data, this is your data set. This is again a very simple data set available on the internet. You have different columns here like customer ID, gender, age, annual income, and spending score. Um, so what you need to do is, based on these features, you need to group your customers. Okay. Uh, right. WCSS is Y here right now. I'm not sure what the question is related to, so I'll try to skip this question. Okay. So I have all these features, and my question here is, I want to group these customers in different clusters. Okay. So I'm going to take this data. So I'll run this piece of code. I'm reading the data, and as part of my x variable I am taking two features right now, because I want to visualize it, right? So I'm only taking the third and the fourth column, which is this and this 0 1 2 3 and 4. Okay, so I'm only taking these two columns. So if you look at my x data, it's 1539, 1581, and so on, right? The reason why I have taken two features is just to visualize the data, because eventually I will be visualizing this data in a graph format, right? Your x here is nothing but um, your x here is annual income, and your y here is spending score. So this is annual income and this is your spending score. And in this graph, there will be different data points. You should be able to visualize the clusters, right? That is the end goal. So I have taken only two features. So here, same piece of code. If I run this code, you will be able to get the elbow method. And you can see potentially somewhere here the elbow is formed, right? Somewhere at 5. So k value can be 5, can be 6, can be 4, can be 7, can be 3 also. You should always do a hit and trial on plus minus 2, right? So let's say first we will try to run it on k-means clustering with clusters 5. Okay, so I'll run this piece of code, and then here I will just comment out these two lines because I only want 5 clusters. So I'll run this piece of code, and you will see that these are my 5 different clusters. And you can see this is your group 1, group 2, group 3, group 4, group 5. Don't go with the names, right? Randomly they have taken names, red as cluster 1, blue as cluster 2, but eventually these are 5 clusters. Right now, if you look at this graph, what you see is potentially 5 different groups of people, right? Green is that group which has the highest income, but the spending score is low, right? Blue is that category where annual income is the highest, spending score is also highest. So these are the target customers. Like for any company, these are the target customers, right? These are also your good target customers because these are people with low income who are not earning a lot, but still they are spending. People who are earning 50,000 a month but spending almost 40 to 50,000 a month. These are this kind of category of people. Blue are those like big people, like rich people, uh, earning 5 to 6 lakhs a month, also spending 4 to 5 lakhs or 6 lakhs a month, right? So this is your first priority. Red is basically medium income, let's say around 2 3 lakhs, and medium spending score around 1 or 1.5 lakhs, right? Yellow is the lowest target. You should not target these people, low salary and low spending score. This one, spending score is low but annual income is high. So you can basically target these people whose annual income is very high but spending score is also around 0 to 20%. So they will buy because they have money, but spending score is low, right? But potentially, if you look at this graph, right, you can still identify that you can further have another cluster like this. This can be another cluster, right? And this can also be another cluster. So let's go ahead and run this code using 7 clusters and see whether the algorithm is able to identify them as clusters or not. So I'll run this piece of code and I will uncomment these lines and I will run this. So you can see the algorithm did not identify this as a separate cluster. See, it depends on the algorithm, right? Uh, so if you take this, so algorithm, instead of making this as a cluster, algorithm created a cluster here, but this one it did properly. So the orange one is the topmost target area, right? Similarly, what we will do is in the next class, in this example, what we have done is we have taken multiple features, right? So maybe we will try to cut it down to 2 features so that we can visualize the data, because with more than 2 features you cannot visualize. but eventually you will be able to see the clusters. Okay, but in the meanwhile, go through that market segmentation use case. That is a end-to-end clustering project that you can use and leverage. Apart from that, we can wind up the class here. This is all about clustering. In case you haven't liked the stream, please like it. And now I will pick some of the this thing comments from the comment box. I will pass on this code to you guys. um, in the meanwhile, you can ask your questions quickly. I'm looking at the chat box in case you have any questions. Those who wish to go for this end-to-end machine learning AI program, just repeating once again, I already have a program which is like a 150 hours program, right? So in case you want to have a dedicated course, 150 hours of videos are already there in this program. I also provide one-to-one support here. I also provide with some sort of um, obviously technical support is also given. Interview preparation support is given, resume preparation support is given. It's a 7999 program. It's not that expensive with respect to what I am offering to all of you. So in case you are interested dedicatedly to go through each and every topic properly, enroll for this program because it's going to be useful. Trust me, you will love it. Because in the free classes on YouTube, I'm planning to take 12 hours, but in reality machine learning cannot be done in 12 hours, right? So only for that, um, this thing, let me just stop my sharing. So only for that reason I'm telling you to take the course, but yeah, it's up to you. Now I'll go through the comments. Okay, um, beginning from, I think I already answered this. It was a good question though. Sir, are you in Hong Kong? Yeah, I stay in Hong Kong, but I am basically from Odisha, India. Um, yeah. Intercept is like a starting point. Yes, yes. Any questions? I'm going through. Encoding is used to convert categorical data to numerical. That's correct. Why reshape? I think I answered you. That is the prerequisite to your standardization model. So 2D, they're expecting 2D data. That's why we need reshaping. Had a job, left job in 2023 as there was no exposure and learning. Struggling from March, haven't been able to score a job yet. Help, please. Sajan, you need to send me your resume and I need to have a check. Then only I can comment what you have, right? What experience or knowledge do you have? Based on that only I can tell you. Um, so how do you decide dependent features if we have more than two dependent features? I think I explained you. Feature selection is a key. So recursive backward elimination or feature forward feature selection, both of these techniques will work. Or the technique that I used was correlation technique, that will also work. Good day, sir. This is my first time understanding what machine learning is, and I've been following a class from the beginning, and I have actually gained a lot. Thank you. Thanks a lot. Give a glance about feature selection. I already give. Mohammed Bukar, I just answered your question. Difference between time series and regression will be covered in the next class. Next Saturday is the most important class. In case you want to join, you should join. Okay. Um, I'll directly go to the latest comments. WCS is great way to target people. Yeah, this is the This was the intention for the clustering. Please pass on the code with dataset. It's provided in the GitHub repository. Please download. After clustering is done, can we convert those clusters into a data frame? Yes, we can. That's why I told you, go through that market segmentation use case. So you will be able to understand. What we have done is we have taken the data, we have done the clustering. After clustering is done, we identified the clusters, and then let's say we have 5 clusters, so we converted the data into a supervised learning data. So now we have 5 clusters, so 5 classes, and then we were able to take that and build a classification model. So when a new customer comes in, you can actually identify which cluster this person is belonging to, right? That's the whole idea of customer segmentation. How are you, buddy? I'm good. Is that Ashwin from DAB Pokhariput? I'm not pretty. I cannot see your photo. Okay, thank you all for joining the class. Um, I think everything is clear. In case you have any questions, let me know in the comment section after the video is published. The video should be visible on my channel immediately, so reach out to me in case you have any questions. Next class we will be joining for time series forecasting. Thank you all. Till then, bye bye.